Hello, 7th graders. This time we're going to look at a very specific aspect of linear equations and their graphs. We're going to take an equation in standard form, 2x minus 3y equals 6. You'll see that this is somewhat similar to the one in the previous video, but it is a different equation, not equivalent to the previous one, and therefore the line is not the same as the other one. And as always, I would urge you to always be looking at a graph along with the equation, make the correlation between the two. That's the number one most important lesson in this area. And of course, you can use Desmos.com. Type in this equation into Desmos.com. It's kind of a spoiler as to some of the things we're going to do, but it's essential to make that connection between the graph and the equation. The very specific thing we're going to do with equations like this is to find out where the graph of this equation crosses each of the axes, the x-axis and the y-axis. Now, I say the graph of this equation. I could, in this case, say the line. This is known as a linear equation because its graph is a line. As we move forward into high school math, we will deal with equations which are not linear. Equations whose graphs are not straight lines, but straight lines are simple geometrically, and the algebra that goes along with them is also relatively simple, which is why we begin with them. Well, the key to this question of where does the line that goes along with this equation, where does the graph of this equation cross each of the axes is this. When x is 0, you're going to be on the y-axis. That might seem a little backwards, but this is very important to get used to this. Whenever the x-coordinate of a point is 0, you're going to be on the y-axis. So what we can do is plug a 0 in for x and solve for y, which we'll do now. Let's do that mentally. Don't have to write out any work here. Very simple. You put a 0 in for x. This first term is 0. 2 times 0 is 0. You're left with negative 3y equals 6. Divide each side by negative 3 and get y as negative 2. If you put a 0 in for x and a negative 2 in for y, you get a true statement. You get 6 on the left equals the 6 on the right. So y is negative 2 when the x is 0. And that point is on the y-axis. This is known as the y-intercept of the line. And to find where this line crosses the x-axis, when you're on the x-axis, the y is 0. So we'll put a 0 in here for y and solve for x. Again, very easy to do mentally. If we put a 0 in for y, this second term will be 0, and we'll be left with simply 2x equals 6. So x is 3. I'm going to switch now, even though I've encouraged you to use Desmos. There'll be times when I'll want to show a graph on a whiteboard. So I'm going to switch now. And what I have here is a what I call a rough sketch of an x and y coordinate plane. I don't have a whiteboard that has blue lines on it like graph paper. It'd be nice if you had some graph paper going forward in the next few weeks and a ruler to do some graphs very nicely on graph paper. But even if you don't have it, on a plain piece of paper, just decide how far apart each of your units, what your unit's going to be. I chose a 1/2 inch here, so I went a 1/2 inch here to the right and got 1, 2, 3, going a 1/2 inch each time. And it works pretty nicely. It doesn't take very long to do. So what I've done here is I have plotted the 2 points that we just got algebraically for this equation, 2x minus 3y equals 6. Let me put that equation on this board, 2x minus 3y equals 6. The first point that we came up with was we let x equals 0, we got negative 2. That's here. This is the point, I'm sorry, it's here. That's the point 0, negative 2. And then we let the y equal 0, and we got 3, 0. These are the intercepts. And not only are they're the intercepts of the line, which is the graph of this equation. And if you had typed this into Desmos, this equation, you would see the line. But let's say you didn't. Let's say you had to do it yourself. Here's a fundamental truth about geometry. And it's about as basic as you can get. Can't really prove it, but it's just one of those obvious things that the whole structure of geometry is built on. They're called axioms or postulates. And this assumption is that if you have two distinct points, two different points, how many lines are there that go through those 2 points? Only one, right? So what we do, we take the ruler, we lay it down so that it's going through the 2 points. And of course, lines are infinitely long. And when I'm having students graph lines in the X and Y coordinate plane, I always urge them to make the line take up most of the paper, or in this case, most of the whiteboard, like that. That's going to be important down the road when we look at 2 different lines and we might want to see where they intersect. And if you just make a little tiny line here and then you have, say, a second one, you might not see where they intersect unless you make them big and take up the whole paper or the whole board. Well, this is the line. This is the line, which is the graph of this equation. And we can see the 2 intercepts geometrically that we got algebraically before. The point 0, -2 is on the y-axis. So that point is called the y-intercept. And this point here, which is on the x-axis, that was the point 3, 0. And since that point is on the x-axis, we call it the x-intercept of this line. So anytime you have a standard form equation like this, it's extremely easy to find the 2 intercepts by plugging in the 0 for x and then plugging in the 0 for y. And once you do that, you've got 2 points that are on the line, so you could connect them, and extend it out infinitely. These arrows indicate that the line is infinitely long, and you have a graph of this linear equation, which of course is a line. So there you go. We'll look at another example. Let's now consider this linear equation in standard form. -x minus 2y equals -3. We want to know where the graph of this equation, which is a line, crosses the x and the y intercept axes. So we put a 0 in for x. That's going to give us the y-intercept. When x is 0, you're on the y-axis. If we plug a 0 in for x, we get -2y equals -3. The opposite of 0, -0 is 0. This term goes away when x is 0, and we get -2y equals -3. And of course, if we divide each side by -2 in order to isolate the y, which I've shown here, -2y equals -3, divide each side by -2y equals -3 over -2. We know, of course, that's positive. It's 3/2. Let's write it as 1.5 this time. Desmos uses decimals. And this is the y-intercept because it's on the y-axis. And now we'll find the x-intercept, which is where y is 0. So we put a 0 in for y. And this term will go away. -2 times 0 is 0. We're left with, when y is 0, -x equals -3. I think we all know how to handle that. You could say, well, I'm going to multiply each side by -1 or divide each side by -1. But just think about it. The answer is obvious. If the opposite of x is -3, then x is 3. So this point 3, 0 is on the x-axis. So it is known as the x-intercept. Let's look at that graphically now. Here's the same equation. -x minus 2y equals -3. We just determined that one point on this line is 0, 1.5. 0, 1.5. So I'll put a red dot there, see, halfway between 1 and 2 on the y-axis. The coordinates of this point are 0, 1.5. And then the other point that we just found was 3, 0. 3 to the right and on the x-axis. So once again, if you have two distinct points, two different points, there's only one line that goes through those 2 points. So if we take a ruler and connect those 2 points, we have the line, which is the graph of the linear equation. So we have taken 2 examples now, equations in standard form that look like this and the previous one. And we found the 2 intercepts, the x-intercept and the y-intercept. Once we had those, we could take a ruler, connect the 2 points, extend infinitely along the ruler, and we have the line, which is the graph of this equation. Let me emphasize the fundamental point in this area to close this video. Every single combination of x and y that makes a true statement in this equation is a point on this line. The x and the y are coordinates of points on this line. And every single point on this line, if you take the x coordinate and the y coordinate, those numbers will make a true statement in the equation. The equation and the graph are 2 sides of the same mathematical coin. They are 2 of the same mathematical truth, 2 mathematical truths that are identical. So we'll close for now. So long.